Let's take a look at some practice problems with points, lines, and planes. The first question is, what lines contain the point V? So the first thing you'd want to do in order to answer this question is to locate the point V. In this case, we notice that V is pretty much in the middle of our figure. And we want to name all of the lines on the figure that actually pass through point B or contain point B. You'll notice that this line right here contains point V, so we can say line RT contains point B. Alright, what other lines contain point V? Looking at it, you might notice that line MN also contains point V. So you could say line MN. Alright, there is one other line that contains point V, and it's the line that goes straight up and down and pokes through the plane. The reason we know that it pokes through the plane is that there is a dashed line going below point V. So starts at point P, goes to V, and then goes down below. So we can name that line line PV. Notice you could have also named line RT as just line A because there was an italicized letter next to the line. So you could say line A. Also notice that line L contains the points M and N, so you could have said line L instead of line MN. And also notice that line PV contains or is labeled with an italicized T, so you could also say line T. Whether you name it with 2 points or an italicized letter does not really matter. The choice is pretty much yours. Just make sure that the italicized letter is next to the line that you're naming. Alright, let's name 3 points that are on line A. So again, this is line A, it's the little italicized letter. And you'll notice there are 3 points labeled on line A. The points are R, V, and T. The reason we know that those lie on line A is because they are all on top of the line that has A next to it. Alright, name 3 points that are on plane J. We have several points to choose from. The way you know if a point is on a plane or not is that it'll generally be on top of or within that parallelogram that is written. Let's go ahead and circle all of those with green. Point R, point M, point V, point N, and point T are all on plane J. The reason we know they're all on plane J is because J is formed by that parallelogram. And since they lie within that parallelogram, we assume that the points are lining on the plane. So you could name any 3 of those points. We could name it R, M, and V, for example. All right, the next question is, are points R, M, T, and N coplanar? That means, are they all in the same plane? In this case, if we look at it, R, M, T, and R, M, T, and N are all on the same plane. So the answer is yes. Alright, we have a couple more questions. Name 3 collinear points. That just means name 3 points that are on the same line. Now, the line you choose is your choice. In this case, we could choose line L, for example. And we could say that on line L, the points N, M, and V are all collinear. So N, M, and V are all collinear. Is line A contained in plane J? So again, this is line A. So it's this straight line right here. And is it contained within line or plane J? The answer is yes, it is. And the reason we know that is because there's not a dashed line indicating that the line starts above the plane, and the dashed part means it goes below or goes through the plane. So is line L contained in plane J? So we here find line L. Again, it's a solid line within that parallelogram, so yes. And our last line to take a look at is line T. So if we take a look at line T, here it is right here. You'll notice line T starts outside of the parallelogram and it continues with a dashed line indicating that it's going through line J. So the answer is no, it is not contained within plane J.